Hey, hey. So we are back in the ratio and proportion section, and unit rates and unit prices mean like per item. So for instance, we use unit rates all the time, things like miles per hour, feet per second, your heartbeat, how many beats per minute, right? BPM, beats per minute. And so we do these things all the time. And if you see the little tags in the grocery store, that's supposed to help you comparison shop. And it may break things down in the price per ounce. So when we're trying to, like make sure we're getting the best buy for our money, obviously there are times it's not going to be more cost effective if like we're going to waste some of it or something like that. But oftentimes, but not always, the larger one is the better price. So to find the unit price, then it's all, see, notice how this says per meter. That's because meter is on the bottom. So this is 189 per 7 meters. And when it says per meter, that means we want this to be a 1. So we just divide. So 7 into 189 would be 27. So 27 cents. Now notice it is cents. So when I put this in, I don't want to put in just 27 without a decimal, or things are going to be wrong. So it's always the price is going to go in the calculator first. So it's the dollar amount divided by the quantity. And the quantity might be how many pounds, how many feet, how many meters, how many ounces, etc. So 1260 divided by 6 would be $2 and 10 cents per pound. Now on a calculator, that's just going to say 2.1, but if we're writing that in dollars and cents, that's not 1 cent, that's 10 cents. There's a 0 at the end that the calculator just chops off. So it's pretty straightforward, just divide. Now, I already tried it a few minutes ago. I didn't have to put the 0. I could just put 0.27, but I do need the decimal point. Notice it's a decimal point with a dollar sign. It is not a decimal point and a cent sign. That would mean it's only parts of a penny. So I'm going to go forward so we can see what happens here. So now we're going to get some things where we have to, notice it says rounded to the nearest cent. So we're going to divide this. See, it's 361 divided by 5, which is going to be 0.722, I believe. And then this is supposed to be rounded to the nearest cent. So cents means 2 decimal places. So I can only keep 2. So I look at the third one. 5 or higher, we're going to round up. 4 or less, we're going to round down. So this is less than 4. So to the nearest cent is just 72 cents. Sorry about that. So 0.72. Now, when it says which is the better buy as in cheaper price per item. So better buy, we're talking better for you, the customer, not better for the store. So we want the lower unit price when we're talking about better buy. So we're going to do the same thing we've just done, but we're going to do it twice. So this gives me 0.26 when I divide. This one gives me 0.25. So the lower of the two would be the 7-pack. So it doesn't mean the overall price is cheaper, it means the price per car is cheaper. So again, this is asking for the nearest cent. So I'm going to divide and then have to round. So a 9-pack for $5.99. Now, when I do this, if I was doing it by hand, it still hasn't actually come out evenly. By the way, if you're wondering what I did here, I said 9 into 59. That was 6 with 5 left over. So I scrunched the 5 next to the next 9. 9 into 59, that's 6 with 5 left over. Then I added a 0. 9, and then 50 divided. What am I doing? Not 8. It's a good thing I talked about it. 9 into 50, I was thinking about the 6. 9 into 50 then would go 5 times. Now, this is going to keep going and going and going and going. But I only need to work out to the third place to decide, is it staying 66 cents or is it going up to 67? So since 5 is 5 or higher, we're going to round up. So it's going to be 0.67. And in this case, even if I had messed that up and left the 8 there, I would have still gotten 0.67. Again, you can use a calculator. I just don't have one in my hand. So let's see, 0.67. Again, better buy, divide both of them, see which one is lower. And as you see, I'm already at 83. Right, so first lesson for that section, this section should not be a problem. If you have time today and you want some extra practice, you could also do C3. I did not recommend it, but you could also do C3. It's just unit rates. It's still the same dividing by the one that's, when you try to decide which way, the one that says per day, that should be the second thing you type in. Now, after we've done that, we have some other word problems with proportions. So remember proportions, we did those last week. And with proportions, we could set up two fractions that are equal to each other and just have one missing part. And then we could always use cross multiplying, but we could oftentimes just see a pattern. So in this case, I see I've got jam and days. So I'm going to go ahead and write these as rates, like jam, the jam on top, the days on the bottom. So this would be 8 things of jam in 2 days. How many days does Anna need? We don't know the days. If she wants 12 liters of jam. So the jam numbers on top and the time, the number of days, is on the bottom. So from there, now I can cross multiply. So that's 8x is equal to 24. And then when we divide, we get x is 3. And you might think, well, the days was like the jam divided by 4. 12 divided by 4 also gives us 3. So more than one way to get to our solution. So 3 days. So I've got kilograms and hours. So I like to write down, just like with a letter, what I'm doing. So, because you need to set it up the same way. You could put hours on top, kilograms on bottom. There's more than one way to set it up, but you need to be consistent. So if I start this side with kilograms on top, then here my kilograms are on top, and we don't know how many hours. That's my mystery number. You could leave it an H instead of an X if you want. So then 10x is equal to 70. So crisscross, cross multiply, divide by 10, and we get 7 hours. And when we read that, it should make sense, right? It's going to take Patrick longer if he's making more dough. So this time we've got money and attendees. So it's $27 for 3 people. How many attendees if the budget is $45? We don't know this number. Now, you can go straight to cross multiplying. I think a lot of us would probably think this is $9 per person. And then if we did 45 divided by 9, we get 5. And let's look if we cross multiply if we also get 5. If I cross multiply, I get 27x is 135. And when we divide by 27, we also get 5. So cross multiplying will always work if you have it set up correctly, but sometimes just intuitively you might figure out the answer another way that still gives us the same solution. And then the last of the C lessons that we're going to do is about scale drawings. And scale drawings, if you hear someone say something is drawn to scale, or maybe you hear them say or read that it's not to scale. So a scale drawing would be like if you had a blueprint of your house. Well, if your living room is bigger than your bedroom, then they should be proportionally sized so that your living room is bigger than your bedroom on the blueprint. If you look at a map, there'll be a scale that says like 1 inch represents 50 miles, or 2 inches is 37 miles, or whatever. You get a matchbox car. It might say 1 to 64. That means it's a scale model that, like, the real thing is 64 times as big. But everything is to scale or it wouldn't look the same. So this one says he made a scale drawing of the campsite. In real life, the tent is 8 feet long. It's 2 inches in the drawing. And they've written this like in a proportion or a ratio with a colon. So just think inches, sorry about that, inches to 8 feet. And then this is 1 inch is how many feet? So if 2 inches is 8 feet, 1 inch would be, that's right, 4 feet. So if the scale says 4 inches, if the scale says 4 inches is 3 miles, and if they are 8 inches apart, how many miles apart are they? So you can cross multiply, or you could just think this is times 2, so this is going to be times 2. Or if you cross multiply, you would have 24 is equal to 4x. 24 divided by 4 is also 6. So the numbers get a little bigger here, but still the same thing. So in the so this is going to be a pretty big drawing if the gem is 129 inches long, because that's like a 10-foot long drawing. But okay. So 3 inches represents 2 feet. So this is like the drawing is the 3 inches. 2 feet is real life. So if this is 129 inches, we're looking for how many feet, the real life part. So again, cross multiply. You could just leave off those labels. So 3x is equal to 458. Why did I say 458? How about 258? Much better. Wasn't going to come out nicely. So 258. And now when we divide by 3, see 3 goes into 25, that would be 8 times 186. So the gem is 86 feet long. So 86. So every time we can use proportions here so far. So here, oh, well, apparently you won't have to worry about this because this is at 81. But this is wanting to know what scale factor does it use. So if 5 inches is 1 yard, to find scale factor, we would need to change them into the same unit. So 1 yard is 36 inches. So 5 to 36. And that does not simplify. Right, so if you try to go higher, then you're going to need to know some things about measurements, like how many millimeters is in a meter. Right? But you're not required to do that. Okay, so as a bit of a bonus, not really a bonus, but just in case while my sub is in the room tomorrow, you have additional questions about I9, which is our other lesson that I already recorded previously. This is about rearranging multivariable equations, which is the same thing as saying solve a literal equation. So you always want to be sure that you pay attention to what's being asked. It's asking for P, solve for S in terms of P. So solve for S is the one we want to by itself. P was already by itself, so that's not going to be what we want. It's pretty straightforward if there's only two things, I guess. And then divide by 4 to get S by itself. So then S is going to be equal to P divided by 4, or P slash 4. Oh, there we go. They actually gave us a little fraction button. So P over 4. And in this case, they want us to get T by itself. It's because it says solve for T. In terms of the rest of that stuff, just means those are still going to be in the answer. So when I look at this, I need to think what is still with the T, the S. So we're going to need to divide by S. And then T will be by itself. So if I come over to my box, once I click on it, I get a fraction bar. On the top, I've got that negative UVR, and in the bottom, the S that had been with the T being multiplied, so to get rid of it, I divided.